Welcome to the Copperfield Electric Podcast.
Glad to be here.
So, tonight at midnight, millions of cars are basically going to secretly negotiate with the global power grid while their owners sleep.
Yeah, it's wild to think about.
Right. And today, we are figuring out how to get your garage in on that conversation. We're talking about transforming it into like a self-thinking fueling station.
Without accidentally blowing your home's electrical panel into the next century, hopefully.
Exactly. No explosions today. We are doing a deep dive into a really comprehensive 2026 guide to residential smart EV charging. And we've got some great background materials, case studies, and internal data from Copperfield Electric down in Southern California to help us unpack this.
Yeah, because buying the EV is, honestly, it's the easy part.
Oh, for sure. The test drive is fun.
Right. The instant torque, just totally bypassing the gas station. I mean, that all feels like stepping into the future. But the reality of EV ownership is that your daily friction points, they shift entirely to your garage.
Yeah, it's a totally different routine.
Exactly. If you don't master the home charging infrastructure, you are effectively buying yourself a second job managing a giant battery.
And nobody wants that. I mean, we all know the baseline setup is functionally useless for a daily commute. Everyone gets that, that level 1 charging cord in the trunk.
The one you plug into a standard 120-volt outlet.
Yeah, exactly. The same outlet you use for a living room lamp. We don't really need to harp on the obvious here, but getting, 3 to 5 miles of range per hour?
Yeah, it's brutal.
It means you are tethered to the wall all weekend just to recoup maybe a couple of days of highway driving. It's literally like trying to fill a backyard swimming pool using a drinking straw.
That is exactly what it's like. It's just not practical. So you really have to bypass that trickle charge and jump to 240 volts, which is level 2 charging.
Right, level 2. So what does that actually look like for the house?
Well, pushing into 240-volt territory,
Yeah.
it completely alters the physics of what is happening in your garage. You are stepping up from a standard outlet draw into the realm of major appliances.
Like a clothes dryer or an electric oven.
Exactly. A level 2 circuit is delivering a massive amount of energy. It suddenly jumps your charging speed from that painful 3 miles an hour up to anywhere between 20 and 40 miles an hour.
Oh, wow. So you are fully replenishing a depleted battery overnight while you sleep.
Right. But, and this is crucial, getting that 240-volt line established is really just the foundation.
Yeah.
Because level 3, the ultra-fast DC charging you see at highway rest stops.
Yeah, the superchargers.
Right. Those require commercial-grade power. That's just not an option for homes. So level 2 is your max. But if you just hang a basic level 2 cable on your wall, you have essentially just installed a dumb pipe.
A dumb pipe for electricity.
Yeah, literally. I mean, it knows how to push power, but it has no spatial or temporal awareness.
Right.
It doesn't know what time it is. It doesn't know what the utility company is charging for electricity at that specific second. And it can't communicate with your home network.
Okay, let's unpack this because I really have to push back on this whole push for smart everything.
I knew this was coming.
No, seriously, I despise the Internet of Things trend where every appliance needs a silicon chip. My toaster does not need Wi-Fi.
Sure.
My washing machine definitely does not need an app. If I have a heavy-duty 240-volt line installed, why in the world do I need my car charger to be on my home network?
It's a fair question.
I mean, I get home at 6 p.m., I plug the car in, the electrons flow, and I unplug it in the morning. Why overcomplicate a really simple transaction?
Because that simple transaction at 6 p.m. is financially penalizing you.
Wait, penalizing me how?
Well, utilities operate on time of use rates, right? Meaning the cost of electricity is dynamic. It changes. At 6 p.m., everyone in your city is getting home.
Yeah, they're turning on their AC.
Exactly. Turning on the air conditioning, cooking dinner, firing up their TVs. The power grid is under maximum strain.
Yeah.
So utilities charge their absolute peak premium prices for electricity during those early evening hours.
Oh, I see.
So if you plug in a dumb charger at 6 p.m., the power flows immediately.
Yeah.
And you are buying the most expensive electricity the entire day to fuel your car.
Wow. So by prioritizing my own convenience, I am inadvertently subsidizing the utility company's peak hour profit margins.
Exactly. You're just handing them money. The smart charger solves this by decoupling the physical act of plugging in from the actual flow of electricity.
Okay, so it acts like a financial gatekeeper.
That's a perfect way to put it. You still plug the car in at 6 p.m. when you get out of the driver's seat.
Yeah.
But the smart charger's Wi-Fi connection It syncs with your local utility rates.
Right.
It holds the gate closed until, say, 12:01 a.m. or whenever the off-peak rates finally kick in.
When the grid demand plummets.
Yeah, and the baseload power becomes incredibly cheap. That's when the charger opens the gate. You basically automate the arbitrage.
Okay, but wait. Modern EVs have scheduling software already built into their dashboard menus,
Yeah,
right?
most of them, yeah.
So I can sit in my driver's seat and just tell the car not to accept a charge until midnight. Why do I need to pay extra for the wall unit to do the exact same thing?
Well, it's not quite the same thing. The onboard vehicle software handles basic timing, sure, but it's often clunky. And it's isolated from the broader energy ecosystem.
How so?
A smart wall charger connects directly to your utility provider's API. It actually knows about sudden rate changes or peak event days, seasonal fluctuations.
Oh, without me having to manually update my car's dashboard interface.
Right, you don't have to touch anything. And more importantly, the wall unit manages the physical health of the vehicle's battery far more elegantly. Which really brings us to the chemistry of the 2080 rule.
Ah, right, the famous 2080 rule. This is the recommendation from the sources to keep your daily charge fluctuating between 20% and 80%, right?
Yeah.
Saving that full 100% charge only for like long road trips.
Exactly. And to understand why that matters, we kind of have to look at the actual mechanism of a lithium-ion battery.
Okay, lay it on me.
Think of the anode inside the battery cell, like a densely packed suitcase.
Yeah.
And lithium ions are your clothes.
I like this. Okay.
So when you charge the battery, you are literally shoving ions into the lattice structure of the anode. It's a process called intercalation.
Intercalation. Got it. So getting the battery up to 80% is like filling the suitcase normally.
Right. The clothes fit, the zipper works, there is no real stress on the seams.
But pushing that charge from 80% up to 100%?
That requires physically forcing the last remaining ions into a space that is already totally packed.
Oh, man. So you are sitting on the suitcase, violently yanking on the zipper.
Literally. The internal resistance skyrockets, which generates a ton of heat. If you use a dumb charger and you just let your car sit at 100% every single night...
You are leaving that suitcase permanently overstuffed.
Exactly. The mechanical stress on the atomic structure physically degrades the capacity of the battery over time.
But the smart charger lets me define that limit in the app.
Yes. You just tell it to cut the flow at 80%. That relieves all that physical stress on the battery chemistry without you having to monitor the dashboard.
Or run out to the garage at 2 a.m. in your pajamas to manually pull the plug.
Right. Nobody wants to do that. And that level of control, it actually extends to the hardware itself. The materials we're looking at highlight smart units like the ChargePoint Home Flex.
Oh, yeah. The adjustable ones. Energy Star certified, right?
Yeah, they're fundamentally adjustable. You aren't just buying a fixed 50-amp charger. You are buying a unit that can be digitally dialed down to 16 amps or 32 amps, depending entirely on what your home can currently handle.
Which is a huge deal because, you know, if you are listening to this right now thinking, great, I'll just buy the smart unit and wire it into that spare 240-volt dryer outlet sitting in the corner of my garage, just hold on a second.
Please wait.
The continuous load math on an electric vehicle is vastly different from a household appliance. The sources actually outline a 5-step setup process.
Let's hear them.
It's basically 1, check capacity, 2, choose your charger, 3, get a permit, 4, install, and 5, set your schedule. But they put a massive flashing warning sign on step 1.
Checking the capacity. Doing the load calculation.
Yes, performing a professional load calculation. Why is that step so critical?
Well, think about a clothes dryer or a microwave. It cycles its heating elements on and off. It might draw a high current, but only for a few minutes at a time.
Right.
An electric vehicle pulls maximum continuous amperage for 8 straight hours. We really have to talk about the thermal dynamics of copper wiring here.
Okay, thermodynamics.
When a heavy load flows continuously, the copper wires actually physically heat up and expand.
Wait, they physically change size?
Yeah. And then when the charging stops, they cool down and contract. Over hundreds of cycles, this micro-expansion and contraction can physically loosen the terminal screws inside your electrical panel.
Wow. So skipping the load calculation and just slapping a 50-amp breaker onto an older panel that doesn't have the spare capacity,
Yeah.
It isn't just a matter of occasionally tripping a breaker.
No, not at all.
Yeah.
You are creating a thermal time bomb. If a terminal loosens, the electricity has to arc across the tiny air gap.
Which creates extreme heat.
Exactly. That is how insulation melts and electrical fires start inside the drywall.
That's terrifying. So a licensed electrician has to perform a mathematical load calculation.
Right. It's actually required by the National Electrical Code. They ensure your home's total baseline draw, plus this new massive 8-hour continuous load, does not exceed the physical rating of your service panel's busbar.
Okay, let's talk about the hard budgets tied to that math, because our 2026 guide lays out the financial realities of this transition pretty clearly.
Yeah, it's not cheap.
A standard level 2 smart charger installation ranges from, well, about $750 to $2,500.
Right.
The smart hardware itself runs $400 to $700. The installation labor, running the conduit and wire from the panel to the garage, that costs between $350 and $1,800, depending on how far your panel is from your parking spot.
Yeah, distance matters a lot.
And then permits add another $50 to $300.
But, that baseline assumes your electrical panel actually passes that load calculation. We have to address the major roadblock here.
Right, the big $4,500 gotcha. If the electrician runs the math and tells you your 100-amp panel from 1985 is totally maxed out, you cannot proceed without a full panel service upgrade.
Which means you are ripping the old box off the side of the house and upgrading to 200 amps.
And according to the 2026 data, that adds a staggering $1,800 to $4,500 to the project.
It completely shifts the scope.
Yeah.
It goes from a half-day wiring job to a major infrastructure overhaul.
And the timing on this is brutal for listeners right now. In the past, people absorbed that blow using the federal Section 30C alternative fuel infrastructure tax credit.
Right, which covered 30% of the costs.
Exactly. But the sources are crystal clear on a really painful reality check. That federal credit expired on June 30th, 2026. It is completely off the table now. So if you're listening to this and budgeting this project today, you are flying solo on the federal level.
Which really forces homeowners to look for alternative solutions.
Yeah.
But if you're staring down a $4,500 panel upgrade just because you want a blistering fast 50-amp charge, there's actually a highly effective practical workaround.
Let's hear it.
You just ask your electrician to configure that smart charger for a 32-amp continuous circuit instead of 50.
Okay, so explain the physics of why stepping down to 32 amps saves the budget.
Well, a 50-amp continuous draw requires a 60-amp breaker and really thick, rigid 6-gauge copper wire.
Which is expensive.
Very. And it consumes a massive chunk of your panel's overall capacity. But a 32-amp continuous draw only requires a 40-amp breaker and thinner 8-gauge copper wire.
Ah, okay.
The thinner wire is significantly cheaper per foot. It is much easier for the electrician to physically bend and route through your walls, and the lower breaker size often fits perfectly into the existing headroom of an older electrical panel.
Oh, wow. So you bypass the need for the $4,500 upgrade entirely.
Completely bypass it.
So you are sacrificing the ability to add, say, 40 miles of range per hour, dropping down to maybe 25 miles of range per hour.
Right.
But over a 10-hour overnight charging window, you are still adding 250 miles of range to the vehicle.
Exactly. For a standard commuter, you will literally never notice the slower speed, but your bank account absolutely notices the thousands of dollars saved on the install.
That's incredible. It is really about sizing the infrastructure to your actual driving habits rather than just blindly chasing the maximum theoretical specifications of the hardware.
Spot on. And for those who absolutely must upgrade their panels, there is a silver lining. The local utility safety nets become critical.
Right, like the Southern California Edison Charge Ready Home Program.
Yes. They are stepping in where the federal government stepped out. They still offer panel upgrade rebates up to $4,200.
That covers almost the whole thing.
It does. Now, it is heavily stipulated, targeting income-qualified households and specific environmental justice communities, but it essentially subsidizes the entire panel swap if you meet the criteria.
That's amazing. Which really brings us to a crucial point about execution, because navigating load calculations and city permits and 240-volt wiring, who is actually supposed to do this work?
A professional. Please.
Seriously. I was reading a fascinating case study in the background materials from Copperfield Electric. They're the service provider who supplied so much of the foundational data for today's analysis.
Yeah, that case study is a perfect warning.
They detailed a scenario with a homeowner up in Anaheim who tried to DIY this entire process. The homeowner watched a few videos, bought some thick wire, and just jammed a 50-amp breaker into a completely maxed out subpanel.
Oh, man.
Yeah. And a few months later, they started hearing a buzzing, sizzling noise coming from the wall right behind their garage refrigerator.
That's the thermal dynamics we discussed earlier. The continuous load caused a loose neutral wire to start arcing, literally melting the plastic casing of the breaker panel.
Exactly. Copperfield Electric was called out for a 2 a.m. emergency troubleshooting visit just to prevent the house from catching fire.
Unbelievable.
They had to rip the melted components out, pull a new permit, perform the correct load calculation, and rebuild the system safely. It is a stark reminder that working with lethal 240-volt continuous loads is not a weekend hobby project.
Definitely not. When you are actively modifying the core electrical infrastructure that protects your home, the credentials and the deep technical knowledge of the professional doing the work are just non-negotiable.
Which is why Copperfield Electric's operational model is so relevant here. They serve a massive footprint across Orange County and Southern California.
Yeah, they cover a lot of ground.
Whether you are dealing with, ruthless coastal building codes in Newport Beach and Costa Mesa, or older infrastructure in Irvine, Anaheim, Santa Ana, Mission Viejo, or Tustin, they understand the local municipal permitting quirks.
That local knowledge is huge for getting things approved quickly.
Oh, absolutely. And they are a family-owned, go-to 24-hour electrician. They don't just guess, they are fully licensed. I actually have the number here. It's LIC. #1094740 bonded, insured, and they background check their crews.
And what is particularly useful, especially for a homeowner who might be paralyzed by the fear of a surprise $4,500 panel upgrade, is their initial approach.
Right.
They offer a free assessment before any money changes hands. They dispatch a technician to actually look at your bus bar, tally up the continuous load of your air conditioner, your oven, your lighting, and give you the exact mathematical reality of your panel before you buy a charger.
Wow, so you know immediately if you can support a 50-amp circuit, or if you need to use that 32-amp workaround we talked about, or if an upgrade is totally unavoidable.
Exactly. It completely strips the anxiety out of the planning phase. And, they aren't just EV charger specialists. They are a full-service operation.
Right. If you are trenching power for a new accessory dwelling unit, an ADU, in your backyard, or if your entire first floor loses power on a holiday weekend and you need emergency troubleshooting, they have the bandwidth to handle it all.
Having a relationship with a local contractor who actually understands the legacy wiring of your home and the highly specific demands of modern high-amperage smart tech, it just bridges a massive knowledge gap for the average homeowner.
So if we distill all this technical data into a blueprint for you, the listener, the path forward is pretty clear. First, abandon the 120-volt wall outlet. It is a temporary stopgap, not a permanent fueling solution.
Right. Step up to 240-volt level 2 charging, but do not settle for a dumb pipe.
Invest in the Wi-Fi-enabled smart charger. Use the app to limit the charge to 80%, which relieves that physical intercalation stress on your lithium-ion battery.
And use the scheduling features to bypass those peak hour utility rates. Keep charging after midnight when the electricity is actually cheap.
And above all, please respect the physics of continuous loads. Never bypass the mathematical load calculation, and let a licensed professional, like Copperfield Electric, engineer the thermal safety of your home's grid.
Definitely. But, looking at all of this automation, it actually raises an incredibly provocative question about the immediate future of our infrastructure.
Okay, where are you going with this?
Well, we have spent this entire deep dive talking about the brilliance of using smart chargers to game the system. Right. Setting the app to hold off until the exact minute off-peak rates kick in.
Right, getting that cheap 12.01 AM power.
But think about the macro scale. What happens next year or in 5 years when every single house on your block has an EV?
Oh, man.
If 30 homeowners on the same street all use their smart chargers to optimize their utility bills, you suddenly have 30 heavy-duty 240-volt loads waking up and demanding maximum amperage at precisely 12.01 a.m.
Oh, wow. It creates an instantaneous, massive spike in demand on the local neighborhood transformer.
Exactly.
The very technology designed to alleviate grid strain by moving charging to the night could end up creating localized micro brownouts because everyone's smart system is independently doing the exact same thing at the exact same second.
Which means the smart chargers of the near future are going to have to evolve. They cannot just talk to your phone and the utility company. They're going to have to talk to each other.
Like a network.
Yeah. Your charger might have to silently negotiate with your neighbor's charger, staggering their start times block by block, minute by minute, just to keep the local transformer from literally melting down.
That's insane.
The technology in your garage will have to shift from being purely self-interested to becoming a collaborative node in a neighborhood-wide energy network.
It is a wild realization. We are not just plugging in cars anymore. We are essentially turning our quiet residential streets into synchronized, decentralized power plants.
It's going to be fascinating to watch how the grid adapts as this technology scales up.
Absolutely fascinating. Well, thank you for joining us on this deep dive. Stay curious out there. Keep asking the hard questions about how your home operates. And remember to reach out to local pros like Copperfield Electric when it is time to build out your garage's future.